Good morning, children. Hope you could complete question 1 from exercise 2.2. Type 2 is to find a quadratic polynomial. You can consider it as the opposite of what we were doing for the first question. The general form of a quadratic polynomial is ax square plus bx plus c, where a not equal to 0. You knew that the maximum number of zeros is 2, and if you are getting the zeros as alpha and beta, the factors are, if you are getting the zeros as alpha and beta, the factors are x minus alpha and x minus beta. In type 1 or in the verification problems, what you were finding is you were finding the factors using one of the factorization method and then moving into the zeros, then finding sum of zeros and product of zeros, and then verify with the relation alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. In those examples, when you consider a quadratic polynomial, the constant term you are assuming as the product and the sum term you are taking it as the coefficient of x. That sum and product is the sum of the zeros and product is the multiplication of alpha and beta. So if you compare with that relation, the quadratic polynomial can be formed with the formula quadratic polynomial is equal to k into, the first term is x square, second term is the sum of the zeros into x, that means the sum, and the third term is the product of the zeros. Or you can simplify and learn as k into x square minus x into sum of roots plus product of roots. Why the minus sign here is, we know that the sum of the zeros alpha plus beta is directly associated with negative coefficient of x by the coefficient of x square, and the general form is always ax square plus bx plus c. That is why the relation of the negative value of alpha plus beta of x. Thus, if alpha and beta are the zeros of a polynomial, the factors are x minus alpha into x minus beta, and from the polynomial ax square plus bx plus c, the relation is sum of zeros alpha plus beta is minus b by a, and the product of zeros alpha beta is equal to c by a. So, when the sum of zeros and product of zeros are known to you, the quadratic polynomial can be formed by the formula k into x square minus alpha plus beta of x plus alpha beta, or k into x square minus x into sum plus product. This concept of forming a quadratic polynomial is required in the next exercise 2, where you are finding the zeros of a cubic polynomial, which involves finding 3 zeros for a given cubic polynomial. By the examples what I am going to take now, you can study how to form a quadratic polynomial, and then you can do the textbook questions on your own. First example, find a quadratic polynomial whose sum of zeros is -6 and product of zeros is 3. The question says that find a quadratic polynomial whose sum of zeros is -6 and product of zeros is -3. This is a direct question and a direct application of the formula. The quadratic polynomial, the formula is k into x square minus x into sum plus product, which is equal to k into x square minus x into -6 plus 3. Here you can see the value of k remains 1 because the value here of the denominator is 1. -6 and 3 means it is -6 by 1 and 3 by 1. The value of k is 1 and therefore the polynomial is x square plus 6x plus 3. Imagine the case when the sum of zeros is 1 by 4 and the product of zeros is -1 by 4. The same way, the question is a direct question with sum and product directly given to you. The quadratic polynomial is equal to k into x square minus x into sum plus product, which is the same as k into x square minus 1 by 4x plus -1 by 4. You can see the value of the denominator as 4 and both the denominators are of 4. Therefore, the value of k you can assume as 4. That is, the quadratic polynomial is equal to 4 into, by replacing the value of k, 4 into x square minus 1 by 4x minus 1 by 4. How to expand it? Each number should be multiplied with 4. 4x square minus 4 into 1 by 4. 4 times 1 by 4 is 1, or it is x. Again, 4 into 1 by 4 is 1 minus 1. Thus, the quadratic polynomial is 4x square minus x minus 1. A third example of this type, let the sum of zeros be half and the product of zeros is -1 by 3. The first application is quadratic polynomial is equal to k into x square minus x into sum plus product, which is the same as k into x square minus x into 1 by 2 plus -1 by 3. When you observe here, the denominators are two different values, 2 and 3. So what will you assume for the value of k is the LCM of 2 and 3. LCM of 2 and 3 is 6. Assume the value of k as 6. Substitute in the formula as 6 into x square minus half x minus 1 by 3. As I told you, 6 into x square is 6x square minus 6 into half is the same as 3 minus 6 into 1 by 3 is the same as 2 as 2. Thus the quadratic polynomial is 6x square minus 3x minus 2. Exercise 2.2, question number 2. A similar, all questions are the same, direct as sum and product is given to you. Please practice on your own and get the answers. It's the same way I have shown you the examples. Another pattern which is not mentioned in the textbook is these questions when I am working out, you can copy in your notebooks. Find a quadratic polynomial whose zeros are polynomial whose zeros are 2 and 3. When I give this question, please make sure to read the question carefully. Find a quadratic polynomial whose zeros are 2 and 3. The questions we practiced were only when directly the sum and product of zeros were given, whereas here the zeros are 2 and 3. The meaning is, whenever you hear zeros, take the first zero as alpha and the second zero as beta. In these type of questions, first you have to work out the sum of zeros as alpha plus beta is equal to 2 plus 3 is equal to 5, and the product of zeros as alpha into beta, 2 into 3 is equal to 6. Therefore, the quadratic polynomial is of the form k into x square minus x into sum plus product, or k into x square minus x into 5 plus 6. It is the same as x square minus 5x plus 6. So questions on finding quadratic polynomial, read and understand whether directly sum and product of zeros are given or zeros are given. If zeros, please call them as alpha and beta separately. The next topic in this lesson is division of polynomials and the division algorithm, that dividend is equal to divisor into quotient plus remainder in case of polynomials also. This topic is very important as the application of this topic, division, is in finding the zeros of a cubic polynomial, as a cubic polynomial can have a maximum of 3 zeros. Once I work out these division sums here, you all will be thorough in finding out the division or in finding out the quotient and remainder, and later on we will proceed only with finding the zeros of a cubic polynomial. The first concept is divide 2x square plus 3x plus 1 by x plus 2. It's very well the same as calling the first polynomial as p of x and the second polynomial as g of x. The first polynomial is 2x square plus 3x plus 1 and the second polynomial is x plus 2. The first polynomial p of x is the dividend, g of x is the divisor. Before arranging, you should see whether the polynomials are in the standard form. Standard form means the power of the variable is in the descending order. That means here the highest power is 2, the next power is 1, and it is a constant term. After making sure that the dividend is in the standard form, dividend, the divisor is x plus 2. The first step is 2x square divided by x. 2x square divided by x. This will be the pattern in each step you are following. 2x square divided by x is giving you 2x The first term you can write the same, and for the second term plus 2 into 2x is giving you plus 4x. When you arrange the numbers here, you should make sure that it's coming right under the like term. Subtracting all the terms in order, this first term always gets cancelled. Plus 3 minus 4 is minus 1x plus 1. The next step is minus 1x divided by x. This gets cancelled. It is minus 1 here. First term you can write the same. For the second term, plus 2 into minus 1 is minus 2. Change the sign, change the sign. Plus 1 plus 2 is 3. Thus, the quotient is 2x minus 1 and the remainder is 3. For the second question, p of x is 3x cubed plus x squared plus 2x plus 5 and g of x is x squared plus 2x plus 1. To check whether they are in the standard form, power 3, power 2, power 1 and constant. You check only the standard form in the dividend. The divisor, it may or may not have all the powers of the variable under consideration. 3x cubed plus x squared plus 2x plus 5 divided by x squared plus 2x plus 1. The difference from this problem is the divisor here is having 3 terms. The method or the procedure remains the same. To get the first factor, 3x cubed divided by x squared is giving you 3x. The first term you can write as such. The second term onwards, plus 2x into 3x is 2 into 3, 6x squared, which will come here. Next, plus 1 into 3x is plus 3x. You can just place your hand here. 2x into 3x is giving you 6x squared. Plus 1 into 3x is giving you 3x. But make sure you are multiplying with the signs and the application of the product of integers properly. You are going to subtract by changing the signs. 1x square minus 6x square is giving you minus 5x square. Plus 2 minus 3 is giving you minus 1x plus 5 as this will be the next step. Minus 5x square by x square is showing you minus 5. First term the same, second term plus 2x into minus 5 is minus 10x. Plus 1 into minus 5 is minus 5. Change the sign, change the sign, change the sign. Minus 1 plus 10 is 9x. Plus 5 is plus 10. We are stopping here, and the rule is when you reach the remainder, please check that the power of the variable is always smaller than the power of the divisor. Once you reach the power smaller than the divisor, the division is completed. The quotient is 3x minus 5 and the remainder is 9x plus 10. Division of polynomials on questions 3 and 4. Please listen carefully and work it out in your notebooks. so that you can make the division thorough in your mind. P of x is equal to 3x square minus x cube minus 3x plus 5. G of x is equal to x minus 1 minus x square. As I have told you, the first concept is rearrange the terms so that the polynomial is in the standard form. But each term should be placed with their sign. Minus x cube plus 3x square minus 3x plus 5, that is the rearranged form of the polynomial. Here it is minus x square plus x minus 1. So the first step of arranging the polynomials in the standard form is done. Checking the dividend to see whether all the powers of the variable is present. Thus here you can see the power as 3, 2, 1 constant. Minus x cube plus 3x square minus 3x plus 5 minus x square plus x minus 1. Please make sure the arrangement in the standard form doesn't mean that you are removing the sign. Arrange the terms in the descending order of their power. But the sign, whatever is allotted to each term, should be placed as such. The first step is minus x cube by minus x square, which shows that it is a positive x. First term can be written as such. For the second term, x plus x into x is plus x square. Minus 1 into x is minus x or 1x. Subtraction. Plus 3x square minus 1x square is positive 2x square. Minus 3x plus 1x is minus 2x plus 5. The next step, as 2x square divided by minus x square, it is minus 2. The first term you can write as such. Second term, plus x into minus 2 is minus 2x. Minus 1 into minus 2 is plus 2. Changing the sign, and changing the sign. 5 minus 2 is 3. Thus, the quotient is x minus 2 and the remainder is positive 3. The example of P of x is equal to x raised to 4 minus 5x plus 6. G of x is equal to 2 minus x squared. Arranging the dividend with all the powers of x, x raised to 4 plus 0x cube plus 0x square minus 5x plus 6. This is the first step, and here only arrangement minus x square plus 2 with the term minus x square plus 2. Here you need not write 0x in the divisor column, only the dividend. Please make sure that you have all the powers of the variables so that it will be easy for you to arrange the terms when it comes with the product. The first step, x raised to 4 by minus x square is giving you minus x square. First term, just copy the same. Plus 2 into minus x square is minus 2x square. Please make sure you are arranging under the same like terms. Check here, here, cancelled. Not needed, you can ignore it. 0 plus 2 is 2x square minus 5x plus 6. Next step again, 2x square divided by minus x square is giving you minus 2. First term remains the same. Second term plus 2 into minus 2 is minus 4. Change, cancel. Minus 5x plus 10. Minus 5x divided by x square. It is becoming as 1 by x or minus 5 by x. The division stops as the power of the variable is smaller than the power of the divisor. Thus, quotient is minus x square minus 2 and the remainder is minus 5x plus 10. While dividing a polynomial by another polynomial, if the remainder is 0, we used to call the divisor polynomial as a factor of the polynomial which is taken as the dividend. If the remainder is 0, we used to call the divisor as a factor of the dividend. Thus, the factor theorem which you learned in 9th standard is, if a polynomial p of x is divided by x minus a, if the remainder is 0, then x minus a is a factor of p of x, or the remainder can be found out using the formula the remainder is equal to p of a. This was a review of the 9th standard topic. If a polynomial is p of x is divided by another polynomial, it should be only a linear polynomial, x minus a. If the remainder is 0, then x minus a is a factor of p of x, or the remainder is p of a. This is the content of factor theorem and remainder theorem, but this factor theorem and remainder theorem is applicable only for linear polynomials, that is, the degree of the polynomial should be 1.